In the vast machine universe, where steel, timber, and time collide, our journey begins. This isn't just a tour of wood processing. It's a saga stretching from AI-driven mega mills to a century-old water-powered sawmill still running on barely 5 horsepower. We start in the forest where sustainable logging is science. West Fraser selectively harvests mature Douglas fir and southern yellow pine, towering trees prized for their strength and uniform grain. Then the machines take over, feller bunchers slicing logs in under 120 seconds with over 30,000 pounds of hydraulic force, guided by millimeter-accurate systems inside climate-controlled cabins. When the timber moves, it moves in formation. 40-ton trucks roll out in coordinated convoys, feeding a supply chain so disciplined that West Fraser can process more than 3 million cubic meters of wood a year, enough to build 120,000 homes. The process initiates at the bucking station, the critical threshold where rough forestry meets industrial precision. While the trees arrive rugged and uneven from the harvest, this stage is defined by calculation. Here, the intuition of veteran sawyers has been superseded by advanced photonics. High-speed scanners profile every inch of bark, generating instant 3D models to map internal defects and calculate the optimal cut. It is a level of insight that sees deeper and faster than any human eye ever could, ensuring maximum value is extracted from every fiber. Once bucked to length, the logs are submerged into vast indoor conditioning basins. These log ponds function as more than just storage. They are an active preservation system that hydrates the timber to prevent checking while acting as a natural sorter. In a clever application of physics, the water separates species by density. Heavier logs sink while lighter ones float, automating the organization process in a controlled, high-tech evolution of the traditional river drive. From the water, logs are ushered into the roundup system and fed into the spindleless lathe, the true mechanical marvel of this operation. Unlike vintage lathes that clamped logs at the ends and wasted the core, this machine cradles the timber on powered rollers, allowing it to peel the log down to a remarkably small diameter. A massive blade shears off a continuous sheet of veneer, unspooling it like an endless wooden ribbon, while the system dynamically adjusts pressure to navigate knots and grain changes with surgical fluidity before guiding the sheet toward the smart clippers. In today's high-velocity manufacturing lines, advanced optical cameras inspect every inch of moving veneer with astonishing accuracy. They detect defects, knots, voids, and discoloration, allowing the system to make thousands of instant decisions. Keep this section, redirect that one, cut here for maximum yield. Hydraulic and pneumatic shears execute those commands with surgical precision, trimming sheets perfectly even as the veneer moves at over 300 feet per minute. Any flawed material is immediately sent to the chipper, ensuring nothing is wasted. The clean sheets move to the stacker, where automated grading systems sort them by size and quality. Premium veneers go to high-end products, while slightly imperfect ones serve structural roles. Vacuum lifts and robotic arms handle the sheets, often thinner than 1/8 of an inch, with remarkable delicacy protecting them until they become part of a much stronger, engineered product. One of the most advanced stages follows: random assembly. To create laminated veneer lumber, LVL, West Fraser uses a proprietary method that pulls sheets from different logs, forest regions, and grades entirely at random. Because natural wood contains unpredictable weaknesses, knots, grain variations, internal stresses, mixing veneers from diverse sources prevents those flaws from lining up. The result is an engineered product far stronger and more consistent than solid lumber, much like a braided rope gains strength from intertwined strands. Diversity, in this case, creates durability. As for rejected veneer and leftover cores, they head to the chipper. Modern chippers don't simply grind wood, they produce uniform, application-specific chips. Some become pulp for paper mills, others feed particle board and MDF production, or end up as landscaping mulch. Processing hundreds of tons per day, West Fraser's chipper turns what once went up in smoke and old wigwam burners into valuable market-ready material. The old wigwam burners that once smoked out entire lumber towns are long gone. Today, waste doesn't exist. Even veneer cores the dent centers left after peeling are reclaimed by a machine called the pointer dogger, shaping each core for conversion into dimension lumber. It looks strange, but it's pure, efficient engineering. All that machinery demands power, and the mill's energy plant delivers. It burns bark, sawdust, and fines in high-efficiency boilers to make steam. Steam that drives turbines, heats kilns, and often generates more electricity than the mill uses. What once burned in open piles now powers the operation, and even the ash returns to the forest as fertilizer. From the stacker, Veneer heads into massive precision-controlled dryers. Fresh sheets can hold more water than wood, so operators follow strict schedules to drop moisture from nearly 50% to a stable 8 to 12%. Too dry and it gets brittle. Too wet and problems follow. Once dried, each sheet faces a final inspection. For LVL, consistency is everything. Nuclear density gauges, moisture sensors, and weight scanners read every veneer layer without touching it, ensuring uniform strength in every finished beam. Finally, it all leads to the heart of the mill, the LVL press, where hundreds of veneer layers are fused into structural beams that can span distances solid lumber could never reach. We've reached the heart of the mill, the press, where individual veneer sheets are transformed into structural beams that span distances solid timber cannot. The process starts with glue. West Fraser applies a controlled layer of phenylformaldehyde resin to each sheet, then stacks them, all grains aligned in parallel. Unlike plywood, this unidirectional arrangement maximizes
everybody be scared and scream going, what did he say? So that's not what I got.
a massive stack sometimes 40 to 50 layers, is fed into a hydraulic press. This isn't a simple clamp. It delivers thousands of pounds of pressure per square inch while heating the stack, activating the resin. The intense heat and pressure eliminate air pockets and create a molecular bond between layers. In about 20 minutes, a solid billet emerges, pound for pound stronger than steel. The billets then move to the finishing line where industrial saws cut them into precise sizes, from 3-inch floor joists to 18-inch commercial headers. Tolerances are tighter than 1/16 of an inch, ensuring uniformity impossible with natural lumber. Finally, each beam is inspected, graded, and stamped. That stamp is a guarantee. Engineers know exactly what load the beam can carry. LVL has revolutionized construction, replacing guesswork with predictable high-strength, sustainable wood products. It's the culmination of centuries of timber knowledge fused with modern automation, delivering efficiency, reliability, and uncompromising strength. This represents a level of predictability that transforms construction. West Fraser stands at the intersection of historical craftsmanship and modern engineering. Every phase of the process, from harvest to final output, is calibrated for peak efficiency and sustainability. While this technology is light years ahead of the water-driven mills and hand-hewn logging of previous generations, it respects those traditions in the best way possible by wasting nothing. It extracts the absolute maximum utility from every log. Leaving the precision and automation of West Fraser's facilities, we now shift our focus. Our journey takes us next to a setting that stands in stark contrast. From West Fraser's high-tech automation, we now step into a completely different world. Lunenburg County, Nova Scotia, where Ivan Corkum runs a sawmill that has been in his family for generations. This is living history. For those who remember when small family mills dotted North America, it's pure nostalgia. For younger viewers, it's a rare glimpse into life before electricity, hydraulics, or computers. Yet Ivan's mill still produces quality lumber efficiently, proving the old ways can be both practical and enduring. The Corcoms have milled timber here since the 1800s. The current mill, built by Ivan and his father, is powered entirely by water. No diesel, no electric motors. A timber and earth dam creates a pond fed by a year-round stream. From there, a wooden flume carries water to the mill, constructed from local spruce and hemlock. Its planks are overlapped, pinned, and sealed with oakum and pitch, some original sections still intact from Ivan's grandfather's era. The flume ends at a penstock, feeding an overshot wheel 12 feet in diameter. As water fills the curved buckets, gravity drives the rotation, powering a massive hemlock main shaft through hand-carved wooden bearings. The motion transfers through a system of wooden gears and belts, including an 8-foot-wide pit wheel with rock maple teeth stepping up the speed to drive the saw. The saw itself, a 6-foot muley blade and a heavy wooden gate, moves up and down via pitman arm, cutting at 150 strokes per minute. The guides, worn smooth over decades, allow the blade to glide effortlessly, with Ivan making only minor adjustments to maintain precision. Watching it in action is hypnotic. Centuries-old craftsmanship and ingenious engineering still delivering reliable, high-quality lumber. While Ivan occasionally inserts wooden shims to fine-tune the blade alignment, the mill's fundamental structure remains rock solid. The log rests on a massive timber carriage that glides along parallel wooden rails. The feed mechanism is a stroke of pure pre-industrial ingenuity. Instead of modern motors, a dog wheel, essentially a large ratchet system, advances the carriage with every revolution of the water wheel. It is simple but brilliant. By manually changing which notch the pawl engages, Ivan controls the feed rate, easing off for dense knots or accelerating through clear grain. Setting the cut is a manual art. Ivan secures the log with adjustable iron dogs and turns a heavy hand crank to determine board thickness. There are no digital readouts or lasers here, only eye and feel honed by decades of experience. Despite this, he consistently achieves tolerances within 1/8 of an inch. The mill processes local softwoods like white pine, red spruce, and eastern hemlock, traditional materials used in the Maritimes for centuries. The resulting product is distinct from today's commercial stock. This is green lumber, sold with natural moisture content and cut to full dimension, meaning a 2x4 is truly 2 inches by 4. The tight grain offers superior stability compared to fast-grown plantation wood. Finally, the operation follows a natural rhythm. Production peaks with the spring thaws and autumn rains, while the low water of summer is reserved for maintenance. It is a business that runs on nature's schedule, not the clock. Safety at a water-powered mill is all about vigilance. With no emergency stops, Ivan has to shut the saw down by hand. Dangerous work guided by generations of family experience. The mill is a hand-built relic. Timber framing, mortise and tenon joints, and weathered siding. Modern tools help Ivan prep and haul logs, but the sawing itself is still pure water power. Watching it run is a thrill. In a world of automation, this mill moves wood with nothing but falling water and simple mechanics. The rhythm, the scent of fresh cut timber, the water wheel, all of it feels alive. And this isn't just nostalgia. Ivan supplies customers who want lumber with real provenance. Local wood, cut the old-fashioned way. Authenticity is his business.
Have come in and said, I can't believe I can stand and talk to you and have a conversation with the mill running. Because the noise is only half. Cut the slabs up. He sawed some for you. Did he? He's gonna saw wood up for the kitchen stove. All automatic. You better.
Our final stop takes us to UK Mega, a Ukrainian powerhouse revolutionizing the industry with their UMG 8001.07 automated production line. While often overlooked, the wooden pallet is the backbone of global logistics, and this machine answers the immense demand by turning a traditionally labor-intensive job into a high-speed, automated process. The UMG consolidates the entire workflow from log intake to final dimensioning into one continuous, efficient stream, eliminating the bottlenecks of manual handling. The core of this system is its massive multi-blade gang saw, designed to process lower-grade timber like pine or poplar. The machine abandons the slow, single-cut method of the past. Instead, it drives logs through a battery of up to 8 independently adjustable blades, stripping a single log into 7 finished boards in one pass. It's a brilliant fusion of efficiency and engineering, transforming raw resources into essential infrastructure with unmatched precision. The engineering depth of the UMG 8001-17 is immediately apparent in the sawhead design. Each carbide tip blade is independently adjustable and secured by hydraulic tensioning systems that automatically compensate for heat and wear during long runs. Post-sawing, the efficiency continues with high-resolution optimization scanners. These lasers map defects in milliseconds, guiding servo-driven cross-cut saws to trim boards with 0.2 mm accuracy. This optimization alone boosts material yield by 15–20% compared to standard cutting, turning what would be waste into usable product. Once cut, the boards enter a high-speed sorting and stacking phase. Photoelectric sensors and pneumatic diverters act like a choreographed dance, routing boards into up to 12 different output channels based on length and grade. The line concludes with a vacuum lift stacking system that builds uniform, stable bundles ready for strapping. This automation removes the heavy lifting entirely, ensuring consistent stacking that manual labor simply cannot match over long shifts. While this system represents a significant capital investment, the return is compelling. The combination of reduced labor costs and maximized timber yield allows high-volume operations to recoup their costs in just a few years. It is modern manufacturing at its peak, efficient, relentless, and precise, standing in stark contrast to the handcrafted world of Ivan Korkum, yet proving just as essential in today's diverse wood industry.